Welcome to Bell Work, day 3 for Group A or day 2 for Group B. Today we're asking the question, what are the possible outcomes when we mix two different substances together? And in general, we're going to be talking about substances that are either dissolved in a liquid or that are already in a liquid form. So I'm just going to be diagramming this out on the board here. The rest of the notes are given on slides today. Okay, so combine, we're going to start out with this, combine two substances. And question mark. All right, to show we're wondering what happens when we combine two different substances. Part of this is review. You guys already know a lot about what can happen, right? Because we could have a chemical reaction. Okay, so that's one possible outcome when you combine substances. You're writing this diagram down in your Bell Work notes. So chemical reaction. How would we know if a chemical reaction had occurred? Oh wait, first I have to draw my, this is how I show there's reaction. Okay, how would I know a reaction had occurred? This is something we've talked a lot about, right? We had our reaction in the bag, which had almost all of the signs of a chemical reaction in it. And so some of those different signs are color change, right? And we can have a temperature change. So I'll say heat or cold. And we could have a change of state. So in the reaction in the bag, we saw a gas formed, but you could also have a solid formed. You can mix two liquids together and get a solid. Okay, and when that happens, the solid is called a precipitate. Okay. Spelled P-R-E, sip, tate. Okay? And so that's describing a solid substance that forms when you mix two liquids. And that is going to settle out of the solution. I'll put that, explain what that is up here. This is the definition of a precipitate, right here. Okay, solid substance that forms when you mix two liquids. All right, that's all the things that could happen if you had a chemical reaction occurring when you mixed your substances. Okay, I had to do an edit there, and now we're going to continue talking about what happens when we combine substances. So we said one of the things that can happen is a chemical reaction. The other thing that can happen is nothing. Okay, so nothing's our other choice here. And so when I say nothing, what I mean is we're just going to make a mixture. No new substances formed and no substances destroyed. We're just mixing two things together. Now, mixtures can be divided into two major categories. One type of mixture is what we call heterogeneous, spelled like this, H-E-T-E-R, hetero, if I could get that right. Okay, so hetero, the prefix, means different. Okay, that part means different. And And in a heterogeneous mixture, it's not the same throughout. You can see the different parts. Examples of a heterogeneous mixture would be something like a taco salad. Loose change in your pocket. And a lot of kinds of cereal, like one of my favorites, Lucky Charms. Those are all heterogeneous. Now, homogeneous, the prefix homo means same. Homogeneous. And that's going to be same throughout. Okay, this prefix means same. So we'll say same throughout. So no matter where I took a sample from this mixture, it would always be the same. It wouldn't be different. And so some examples of that might be a latte that you get at Dutch Brothers. Or one of my favorites, which is chocolate. And it is a solid, but solids can also be mixtures. And I'm not entirely sure what all is in chocolate, but I know there's sugar and fat and cacao. All right, so those are two big categories of mixtures, but with our homogeneous mixtures, we have a special set that is called, should I write that one in, a solution, okay? So this is a kind of homogeneous mixture. I'm going to circle homogeneous. Come over here to a solution. Whoops, spelling again. Okay, so a solution, everything's going to be the same throughout. The difference is that the particles are really, really small. So we can't see the particles or individual substances. We'll say can't see particles. And because of that, it is clear, meaning we can shine light through a solution. Okay, so an example of a solution would be something like a soda, like Pepsi, like that, or Coca-Cola, any kind of soda, an awful lot, any kind of clear beverage is going to be a solution, or it could be a broth, or just salt dissolved in water, like the ocean. Those are all solutions. Okay, so in the next video, I'm going to talk about why we're interested in this right now. We are going to be doing chemical reactions called double replacement reactions, and we're going to be trying to decide if we have a chemical reaction or if we're just making a solution. Two liquids mixed together in this case.